as you can see, they say the logarithm to the base y of a number x is the index z, which is equal to the number x, the logarithm. So what does that statement entails? For example, if I have x, y, and z to be real numbers, for an example, and we see that x is equal to y to the power of z. As you can see, y is the base of x. So if you look at this particular equation, you come to understand that z here is called the power and y is the base, while x is the number. That is synonymous to saying that 9 is equal to 3 is to the power of 2 in index form, where we accepted that 2 here is the power, 2 is the power here, and then 3 is the base, and then 9 is the number we're looking at. So if we talk about logarithm, to changing these numbers, this particular equation to a logarithm, okay, let me look at this one first. Z here, we first of all target the power, which is z here, the power here, which is z. That is what we target. So the power is the logarithm, or you say the index is the logarithm of the number x, while y is the base. So if I want to convert this to logarithm, we can write it as saying that z is equal to the logarithm of x base y. So this y here, which is the base, is beneath, is down of x. So we say z is equal to the logarithm of x base y. If I want to convert this to logarithm, all I have to watch out for is the index or the power, because the index or the power here is the logarithm. So we say that 2 is equal to, because 2 is the power, we are looking at the logarithm of 9. And what is the base? The base is what? 3. So what we see here is this form is called the logarithm form. This is called the logarithm form, what we see here. While this form here is called the index form. So 9 is equal to 3 to the power of 2 is called the index form, while 2 is equal to the logarithm of 9 base 3 is called the logarithmic form. So I want to take us right into how we can change from index form to logarithmic form. So say write the following index forms in the logarithmic form. So that is index form. For example, if we have 25 is equal to 5 to the power of 2. This is in index form, as we know. So if I want to change this from this index form to its logarithmic form, logarithm form, what we watch out for first is the power here, and the power here is what? The power is 2. So we write that down, and it's equal to, and this is the number we're looking for, the log 25. So we say the log 25, and this 5 here is the base, so keep it below. So changing 25 is equal to 5 to the power of 2 to logarithm form is 2 is equal to the log of 25 base 5. So let's look at another typical example. For example, if I have 8 is equal to 2 to the power of 3, and I want to change this from 8, and this is index form, this is an index form, let me write here index form. So I want to change this from this index form to its logarithmic form, just like what I did here. So all I have to do first is to watch out for the power here. The power here is what? 3. So I write that down, is equal to, and the number we are changing is the logarithm, that is 8 here. So we say the log of 8. So log is just the short form of saying logarithm, while 2 is the base, so we say 2. So changing 8 is equal to 2 to the power of 3 to logarithmic form is 3 is equal to the log 8 of what? Base 2. So as it goes, if I want to change another number, let us say, for example, if I have a number, say an index form, say the logarithm of 0.01 base 10 is, if I have a number, say 1 is equal to 81 to the power of 0, and I want to change this to logarithmic form, this is, I'm going to watch out for the power, which is what? 0. Yes, the power here is 0. So 0 is equal to the log, and the number we are looking for is 1. What is the base? 81. The same thing applies. If I want to look for the logarithm of 8 is equal to 64 to the power of 1 is to 2. This is very simple. The first thing I look at for is the power, which is 1 is to 2 is equal to, this is the number we're changing to log, so that is log of 8. 64 is the base, it comes down. So that is 1 is to 2 is equal to logarithm of 8 base what 64. So what we did is changing from standard form, from index form, this is called index form, this is called index form, to what standard form, which is this. So this is called the standard form, while this is called the this is called the logarithm form, this is called the what, the logarithm form. So we change from what, index form to logarithm form. So let us check the reverse process. How can we change from logarithmic form to index form? So that is the reverse process. So let's check that. So for example, if I write the following logarithmic form, the following logarithmic forms in their what, in their index form. So we want to change the following logarithmic form in their index form, unlike what we did before. So what we did before was changing from index form to what, logarithmic form. Write the following index forms to logarithmic form. That is what we did before. But this time around, we are going to write the following logarithmic form to what, to index form. So let us see how that is being done. So for example, if I have the log of 8 base 8 is equal to 1, and I want to change this is in logarithmic form, and I want to change this to 8 index form. Now what you look out for is this number that is alone, the number that is alone, which is 1 here, that does not have any log. So this number here is actually called the power, while this number here is called the base. That is the 8 below there is always called the base. So this is called the base, this is called the power, why this is the number we are actually going to change to its what, to its index form. So we look at this number which we are changing, which is 8. So we write it down, 8, that is the number we are changing. So this number here is the base, the 8 here is the base, so we say it's equal to 8. So we take this number 8 is equal to the number, the base 8, and this number on the right hand side 1 is the power. So 8 to the power of 1. That also applies to if I want to change the logarithm of 2 of 8 is equal to 3. So this is also the same thing. The number we are changing here is what, is 8. So we write that down, 8 is equal to it seems I have an ugly way of writing 8. So we write that down, which is what, 8, and this is equal to, then the base, we write down the base, which is what, 2, and the number alone at the right hand side is the power. So yeah, that is 3, and you know that 2 to the power of 3 is what, is 8. So that also applies if I want to also get something of this nature. Say I say the log of 0.01 base 10 is equal to minus 2. I want to convert this to its index form. This is very simple. So the first thing we look at for is the number we are converting, which is 0.01. So we say 0.01 is equal to then the base here, which is the 10. So 10 raised to power what, the number alone, minus 2. So this will give us the what, the index form of this what, logarithmic equation. So that is very simple. So let's go to the next section, which is the laws of logarithm. So there are some few laws we have to obey when it comes to logarithm. So there are so many of them. I'm going to show you the most important ones in this concept. So I'm going to explain this in a very simple way. I'm not going to be deriving or trying to show the proof of each of these laws. I'm just going to state it and make us understand it. So for example, if we are looking for the logarithm, if I have the logarithm of this base b and the logarithm of two numbers, say p and q, the logarithm of two numbers p and q multiply themselves. This is p is a number. If p is a number, q is a number, and it's being multiplied, that's why I say p q. That's p multiplied by q. So the logarithm of p multiplied by q base b is equal to the logarithm of, it's equal to the logarithm of the first one that is equal to the logarithm of p base b plus the logarithm of the second, that is q base b. So this is actually saying that the product of log is equal to the sum of log. That is another name for this rule. The product of log is equal to the sum of log. So if I have two numbers p and q, and I'm looking for the logarithm of these two numbers p and q base b, it must be in the same base. It is just the same thing as saying that this is the logarithm of the first one, b, then multiplied by the logarithm of the second one of same base. Say base what? Base b. So for example, if I want to look for the logarithm of 0.01 multiplied by 2 base 10, this is the logarithm of two numbers. As you can see, this is the same thing as saying the log of 0.01 base 10 multiplied by the log of 2 base 10. So all I just did was to take the log of the first one. This is addition, addition. When it comes to multiplication, it becomes addition. So when it comes to multiplication, it becomes addition. So that is the log of this plus. So this is multiplication here. So this would not be addition. So let's look at the next law. Number 2. The next law is the division law. That is, we create the division. So that is the division of logarithm, that is p and q base a. That I want to find the logarithm of p, the number p being divided by the number what q, is actually the subtraction of both logarithms. So the subtraction of the logarithm of p of same base a minus the logarithm of q base a. So if I have two numbers p, q, and I want to find the logarithm when it comes to division, so the division of logarithm is the same as the subtraction. It's equal to the subtraction of the individual logarithm of the two numbers we are dividing. So if I have two numbers I want to divide, so it is the logarithm is this is the subtraction of the log, the second, that is the denominator from the word numerator. So let us take a typical example. So a typical example of that is if I want to solve, say, the logarithm of base 10. For example, I'm looking at 0.32 divided by 3.43. This is the logarithm. So this is the same thing as saying, this is, for example, I'm saying logarithm of 10.32 base 10. So now it is subtraction. So we're saying it is division. So it will be subtraction here. So the logarithm of 10 of what? 3.34. So it's very simple. When you see division of numbers, when it comes to logarithm of same base, all you have to do is to subtract those bases off. So let's look at the next one, that is number 3. So the next law we are going to look at is, they call it the power law. The power law. So if I have for example, if I have the logarithm of a number, say p, having a power there, n base a, this is the same thing. This is just simply taking this power n, the power you have here, n. So I'm going to take the power n and I'll multiply it back by the logarithm of p base a. Very simple. And this will give me n log p base a. So when you have power in a logarithm, that is something of this nature, n logarithm of a of p to the power of n base a, all you have to do is to take this power, multiply it back, everything. So n, and get rid of the power. So n multiplied by log of p base a is equal to n log p base a. Let us take a typical example of that. For example, if I want to look for the logarithm, if I want to look for the logarithm of a number, say I want to look for the logarithm of 10 to the power of 1 is to 2 base 5. This is the same thing as saying 1 is to 2 log of 10 base 5. So all I have to do is to take the power to the back and multiply it by the logarithm and get rid of the power. So that will just give us what we need. So this is very simple and very direct. So let's take a look at another one. There is this one I would like us to also know, because I'm going to apply it in a question I'm going to solve. The logarithm of a number p base q is the same, is equal to the inverse of the logarithm of q base p. So it's just very simple, as you can see. So the logarithm of p base q is the inverse now of q base p. That is like saying, as an example, I said logarithm of 22.32 base 1 base 10 is the same thing as saying 1 divided by the logarithm of 10 base 2.32. I'm just assuming this, for example. So I'm not going to switch this, take the base to be the number and take the number to be the base and take the reciprocal of it. So that will just give us that. So this is, for example, taking this to be a typical example of what we are just doing for an instance. So there's another law I would like us to see, another interesting law, that is the logarithm of 1 to the base, to base b, that is any base, is equal to 0. So if I have the logarithm, for example, the logarithm of 1 base 10 is always 0. If I have the logarithm of 1 base 100 is always 0. So the logarithm of 1 to any base of your choice is always a 0. So that is one law that is very, very important for us. So I haven't quote all this law, explaining all this law. I would like us to use this law to solve some problems. So let's look at a problem here on logarithm. So let's look at solve the following logarithmic equation. The question says solve the following logarithmic equation. I hope that is correct. I'm more of mathematics, logarithmic. I hope that is the right correction. I hope that. So let's solve the following. So say the log of 81 base x is equal to 4. So I would like us to solve this one first. So if I want to solve this problem, the log of 81 base x is equals to 4. So we are solving the following logarithmic equation. Here in this problem, we want to find the value of x. So what is x in this kind of problem? So I'm going to say solution. So we have the logarithm of 81 base x is equal to 4. So first of all we are going to do, when you see a question of this nature, all you have to do is to convert it from this logarithmic form to its index form. So that is the first thing we do. So I'm going to change this from its logarithmic form to its index form. How do I accomplish that? So this is very simple. I explained how to change this. That is the first part of this video. So we take this number we actually want to change, that is 81. So we say 81 is equal to, x is the base here. So x and 4 is the power of 4, as we can see. So now 81 is equal to x to the power of 4. Now how do I convert 81? Well, okay, the question you ask yourself is, what number is to the power of 4 that will give me 81? That is the left hand side. So that I can actually just equate and get the value of x. And that number is 3. Because 3 to the power of 4 is 81. So this is equal to x to the power of 4. So if we do this, that's we are saying that x is equal to 3 in that scenario. So as simple as that. So you change the logarithmic equation to standard index form, and then you solve the equation you have after that. So let's solve another question for more understanding. So let me take question B. Let me say, for example, I have 1:2 log 64 base x is equal to 3. So I told you before, when you have something of this nature, I'm looking at the left hand side. So the left, if you look at the left hand side, is something that has to do with the power rule I told us once before, that if you have something of this nature, that the logarithm of a b raised to power n is the same thing as n the logarithm of b base a. So I'm taking the power and multiplying it there. So what is the same thing we are going to do into the right hand side of this particular logarithmic equation. So this is the same thing as saying the log of 64 to the power of 1 into 2 base x is equal to 3. So 64 to the power of 1 over 2 is this root of 64, the square root of 64. So and the square root of 64 is 8, because yes, 8 times 8 will give me 64. That is true. So that will say the log of 8 base x is equal to 3. So now I can just solve this. I can change this to 8 index form and then solve. So this is 8 is equal to, the base is x to the power of 3. So 8 is equal to x to the power of 3. So what number is to the power 3 will give me 8, and that is 2, because 2 to the power of 3 will give me 8, and then x. So from here we conclude that x is equal to what? 2. So that's very simple. All you have to do is to know these laws, and then you can just solve simple questions that has to do things like this. So let's we're going to solve. So let's go to there. We're going to solve some questions. Say simplify. So let's simplify this. We're going to simplify 2 log x base 10 minus 3 log 2x base 10 plus log x square base 10. So we're going to simplify this as fast as possible. So we're going to be applying the laws of logarithm we know. So this first one is obeying the power law. So this will be the same thing as saying log x. So this 2 will be the power. That's 2 base 10 according to the power law. Minus, same thing happens here. This will be log 2x raised to power 3. The 3 will be the power base 10 plus log x square base 10. So we're going to take like terms. You see, this is x square and this is x square. So we're going to take like terms. That will be log x square base 10 plus log x square base 10 minus, now this is log 2x to the power of 3 base 10. So at this point we are going to apply the laws of logarithm we know. When it's addition is multiplication, and when it's subtraction is division. So plus 3x plus 3x then plus 9 is equal to 0. So I'm going to group this. We are doing factorization by grouping. I'm going to group this too. So I'm going to factor between x squared and 3x. What is common? So I'm going to factor the common term there, and the common term there is x. So I factor out x. I've taught this before. I will give you the video, you learn it, and then you can come back to this video. It's down the link. I'm going to give you the link. It's on this video. Just check the description. So this will give x will remain here, x will be left, plus what will be left here is 3 after factoring out x, plus. So what is common between 3x and 9, what is common there is 3 plus 3. So if we do that, what will be left is 3 here, and what will be left here is 3. So this is equal to 0. So I'm going to take one of these numbers in the bracket, that is x plus 3, and then what we have here is what? X and then plus 3, and everything is equal to 0. So I'm going to equate each of them individually. So if I equate it, we have just x plus 3, x plus 3. So it will give us x plus 3 is equal to 0. So x itself is equal to minus 3 twice. This is twice. Yes, because we have it twice here. So this is twice. So that is the value of x in this logarithmic equation. So let's look at another example to indulge more understanding on this. So let me look at another example. So we're going to solve log of x squared plus 7x plus 21 is equal to 2, and this is in base 3. Seems all we are doing is in base 3. That is nice. So I'm going to convert this to 8. So this 8 index form. So we're looking for x. We are solving for x. So if I convert this to its index form, the number we are solving for is x squared plus 7x plus 21 is equal to, this is 3. So this 3 is the base. So 3, which is the base. This is 2, which is the power. I taught you this before as we started this video, how to convert from logarithm form to index form. So this is now very simple for us to just switch. We can just squash this as fast as possible. So this is 3 to the power of 2, which is 9. You all know. So this will be x squared plus, this getting more interesting and beautiful, plus 21. So this is 9. I bring it over to the left hand side. It becomes minus 9. And we'll be left with 0 here. So let's do this. It's becoming more interesting. So this is x squared plus 7x. 21 minus 9 is plus 21 minus 9 is 12. Yes, 12 is equal to 0. So we are almost there. So this is a quadratic equation. All we have to do here is to use factorization method. So this is, if I do that, this is 12x squared. What are the factors of 12x squared? That when I multiply it, give me 12x squared. When I add, it gives me 7x. And that are 3 and 4, 3x and 4x. So in place of 7x, I'm going to put in 3x and 4x. So we have x squared plus, I'm going to put in 3x in place of 7x and 4x to in place of 7x plus 12 is equal to 0. So this factorization by grouping. I'm going to group this. They are friends, they are family. I'm going to group this, I'm going to group this. So what is common? That the next thing. What is common between x squared and 3x? Yes, x is common, we know. So what will be left here is x plus, what will be left here is 3. There is between 4x and 12, what is common? 4 is common, because 4 can divide, each of them can be divided by 4 without no remainder. So 4x, what will be left here is x. 12 divided by 4, what will be left here is 3. And this, everything is equal to 0. So we take one of the brackets, x plus 3. So we have x plus 3, we take it into, we take this x plus 4, x plus 4. Nice. And everything in there is equal to 0. So this point, we're just going to equate each of them to 0. So is either x is plus 3 is equal to 0. If I do this, this will give me that x. If we solve this, x will be minus 3. And another value of x is for when x is plus 4 is equal to 0. X plus 4 is equal to 0. So if we solve for x, x is equal to minus 4. So these are the answer. We have x is equal to minus 4 or x is equal to minus 3. So that comes to the end of this video. Subscribe to this channel because we're going to be dropping more videos on things like this. I have more complex problems to solve on logarithm, and I'm going to do it in the next video. Subscribe, click on the bell, stay tuned. Thank you for watching.